Hello everyone, in this video we will be looking at similarity and congruency. So when we talk of congruency, what we mean is two triangles which are exactly equal to each other, identical. That means the angles will be the same, the sides will be the same, and to prove that we need to show that two angles and a side is one way of proving it. So you show two angles of one triangle equal to two angles of the other and one side, or side, side, side. So you show all three sides equal to all three sides, or you show two sides and the included angle. Two sides and the included angle. But now this is congruency. But what is similarity? Two triangles are similar if one is a zoomed in version of the other. So for example, so let's say we have triangle ABC and PQR. So A is equal to R, okay, C is equal to Q. So the third angle is anyways the same, but the sides are not equal, okay. So such a case they are called similar. To prove similarity, you either show angle, 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 okay. You show any two angles equal to any two angles of a triangle equal to two angles of the other triangle, or you show that side ratio of two sides is the same. For example, you show that AC and QR is equal to AB by PR, and you show that the included angle is equal. So that way also you can prove similarity, okay. Either of the two. The result of similarity is, so triangle ABC is similar to triangle, so A corresponds to R, B is P and C is Q. So ABC is similar to RPQ. As a result, what happens is the sides will be in proportion. So we have AB over RP. Always write it in proper sequence, okay. A corresponds to R, B to P and C to Q. So AB over RP equals BC over PQ equals AC over RQ. If I call this the side ratio, let us say M by N, the sides will be in this ratio. So then the perimeter ratio, which is just the ratio of the sides, is also M is to N, and the area ratio will be the square of M and N, M by N squared, okay. So these are the properties of similar triangles. Let's take an example. So here we have this right angle triangle, right angled at B. You have drawn AD perpendicular to it, BD perpendicular to the hypotenuse AC, and the sides given 8 and 2. You have to figure out the length of BD. Here if you look at this angle is, let's say, X, this is 90, so this would be 90 minus X, this is 90 degrees, so this is X 90 and that's 90 minus X. So if you look at the two triangles, the small ones, ABD is similar to triangle BCD, same set of angles. Let's write down the ratios. So now if I plug in the values, AB and BC are not known, so let's skip that. BD over CD is equal to AD over BD, cross multiply, and we get the length of BD without having to use Pythagoras theorem. So that's one way of doing this. We can obviously do it by Pythagoras theorem, okay. So you can take this as x, then this is h squared plus x squared here, root over, and then x squared plus 4 here, root over, then square these two and equate it to 10 square, and then you solve for x. But this is much more simpler. So in fact, you will observe that each of these smaller triangles is similar to the triangle, because that also is the. So if I write down the properties for a right angle triangle like this, remember easy to remember. With respect to point D, dB squared is dA times dC. With respect to point C, CB squared is CA times CD. And with respect to point A, BA squared is dA times CA. Okay. So, BD square is dA times DC, CB square is CD times CA, AB square is AD times AC. So, these are the three relations that we have. Another relation that comes out is equating area. So, half times AB times BC is half times, and we cancel out the half, is half times AC times BD. This also is there. So, it's worth remembering these four things in a right angle triangle. I hope this was clear. Thanks for watching.